Hello, everyone, and welcome back to Virtual IoT and Edge Days 2021. A great session coming up on leveraging Sparkplug to accelerate DataOps and machine modeling into AWS services. So our two presenters today, one of them at least is well known in our ecosystem. So Arlen from CirrusLink. Arlen is the co-creator of MQTT and now a co-founder of CirrusLink Solutions, and CirrusLink being a strategic member of the Sparkplug working group. And with Arlen is Pugal Janakiraman. Pugal is in worldwide business development for industrial IoT at AWS, working with AWS partners such as CirrusLink and others. Is an industry professional with more than 25 years of experience in the space, and certainly looking forward what he has to say about Sparkplug used in the context of AWS. So Arlen, up to you.
All right. Thank you, Frederick. Appreciate it. Hello, everybody. Good morning, good afternoon, good evening, depending on where you're at. We're really looking forward to this. We hope this is an interesting presentation on how we're leveraging a lot of the technology that we're looking at with MQTT and with Sparkplug, and actually putting that into play as we try to start doing this, what everybody's talking about, digital transformation and Industry 4.0 and so on and so forth. So again, my name is Arlen Nipper, and I'm glad to be joined by Pugal. And we're going to kind of take you through our experience of probably the last 4 or 5 years of working together with customers as we've evolved going forward. One of the things I just kind of want to open up with is over the last few years, we're gaining more and more market share. So this is, CirrusLink's engagement, if you will, with customers using MQTT Sparkplug. And we've kind of divided it up into sectors here where I think, when we first started, we were predominantly oil and gas. As Frederick said, I was working with Andy Stanford Clark of IBM in 1998, 1999. And Andy and I, unbeknownst to, we invented this thing called MQTT, and it was for operational data. I mean, that was originally what MQTT was invented for. But as we can see here, last year we had a huge growth in the manufacturing section, transportation, water, wastewater. I think this year, by the end of the year, we're going to see very large growth in the food and beverage and the pharmaceutical sectors. But regardless of what we're looking at, this has definitely been adopted across the industry verticals going forward. Now, for the last 5 years, I've kind of had this mantra is that, if we're going to think about digital transformation, if we're going to think about IIoT, then we've got to really change our mindset from the way that we've been doing automation for the last 40 years. So, I got out of Oklahoma State in, late 1970s, early 1980s. So I've seen 4 decades of us kind of replicating the same thing that we've been doing. The way that I look at operational systems in 2021 and the way that I looked at them in 1980 when I first went to work for Coke Oil really hasn't changed that much. So we need to change our mindset. Let's think about, if we really want digital transformation, we need to stop connecting devices to applications and think about connecting devices to infrastructure, so that we wouldn't think of any other internet application or browser application where we hard coded one application to another, but we're still doing it in the industrial sector. Number 2 is that for 40 years, we've been working with protocols, and protocols create a data register and a value. So we have these register value pairs that are nebulous, they have no context, and what do? We keep having to edit those every time we get a new PLC or a new sensor out in the field. And we need to be able to start providing a single source of truth for all of our measurements. Now, originally, I was just saying measurements, but now Pugal and I have figured out that it really goes up a level, is that we should be able to provide a single source of truth from not only the measurements, but the model of the machine that we're trying to simulate as well, or to model. And then finally, we are talking about OT systems. We're talking about factories or water and wastewater or oil and gas. So we need to still be cognizant of being able to demonstrate a superior OT solution first and foremost. So I think we've all been in this situation where we said in a meeting, and it could be with Amazon, Microsoft, Google, IBM. All of the cloud providers have very compelling technology, and they go through all the stuff that we could do with that. And then we ask the question, well, how could I leverage that in my factory or in my manufacturing or in my food and pharmaceutical? Oh, well, it's easy. Just all you have to do is connect in your OT data. And so if you look at the PowerPoint drawings, it looks simple. But I think here we are 6, 7, probably 8 years down the path, and we're finding that the reality is that it's difficult. We have entrenched devices, we have tribal knowledge, we've got proprietary siloed data. And so we need to look at this as how can we come out with technology that lets the OT side of the business get a infrastructure that is ready for cloud, and kind of flip it around. So instead of IT down to OT, it's going to be OT enablement up to IT tooling. Now, the thing that we've got to realize as we go into this journey is that we've got, and when I say OT versus IT, this really isn't a confrontational statement here. This is a statement of fact, is that right now, for the next decade at least, we're going into brownfield factories. We're going into brownfield infrastructure that consists of proprietary protocols, no contextual information coming from the devices, pole response protocols for data retrieval, isolated networks. So this is a reality. And the other reality is that IT need to be able to understand that information. And so one of the challenges that I always think about as we're thinking about, Sparkplug and digital transformation is how can we take something very proprietary, like a device, and one of the good example is a flow computer on an oil pipeline, has all these enumerations and all of these cryptic tag names, we don't have a clue. And how can we make that humanly understandable by the rest of the company? And really that's our job, is to take that data and make it humanly understandable, consumable by IT and all the data analysts at large. Now, one of the other notions that with Pugal and I working with customers is we're starting to understand that there's been a new kind of a market emerge. And I won't say it's new in that we've been doing this for the last 40 years. But now somebody put a moniker to it, and that moniker is called DataOps. And if you look at the wiki definition, it's an automated, process-oriented methodology used by analytics and data teams to improve the quality and reduce the cycle time of data analytics. Now, they're saying here that DataOps is a new category that addresses the data architecture needs of industrial companies as they adopt Industry 4.0, digital transformation, and smart manufacturing. And really what DataOps means is that we need tooling and we need technology to take nebulous register value pairs and contextualize those so that by the time they get into our infrastructure, we know what they are. A good example is I think everybody here, one of the most ubiquitous industrial protocols is Modbus. And if I'm using Modbus, I get register 40,010, and it's got a value of 1,252. Well, is that 1,252 degrees? Is that 1,252 gallons? I don't know what that is. So I have to double click on that register value pair, and I got to give it a name. Instead of 40,010, I'm going to call it suction pressure. And it's scale it's raw 0 to 4095. I need to scale it 0 to 100 somethings, and those somethings are going to be called PSI, right? But we need to get that technology to be able to do that, get it all the way to the edge or all the way into the sensor, if at all possible, going forward. So how are we going to do that? So we're looking at two pieces of technology here. We're looking at a transport layer, a message-oriented middleware, utilizing MQTT. And you all have probably heard me talk about MQTT. You know, the PAHO project is an excellent resource within the Eclipse Foundation to go learn all about MQTT, to get reference implementation code. And so that's our transport. And one of the ways I look at that is that if I look at the Internet of People, it exploded because we had a transport called HTTP. Well, in the industrial sector, we've got the same thing. It's called MQTT. And the other thing that I like about MQTT as we go into this discussion is that it's leveraging a knowledge base that a lot of people know about MQTT. If I go to universities and I talk to, you know, electrical engineers or data scientists, and I've got them in the auditorium, and I say, of you engineers that want to go into automation, which is really fun, by the way, how many of you have ever heard of OPC UA? Raise your hands. Nothing. Modbus, HART protocol, DMP 3.0, Allen Bradley DF1, nothing. But if I ask those same college students, how many of you have a Raspberry Pi? You're probably using Node-RED. You've probably downloaded the Alexa app from Amazon. You're talking to Alexa, having it send MQTT commands to your Raspberry Pi to turn an LED on and off. And typically a lot of the engineering students will raise their hand. Yes, we do that. We know about MQTT. So the thing I like about that is it's well known and it's cross-discipline. Now, if that is the HTTP of the Internet of Things, we need an HTML part of that. So the great thing about MQTT is you can publish anything you want on any topic. But for interoperability, the bad thing is you can publish anything you want on any topic. So that was kind of the genesis of why Sparkplug was created. We needed an HTTP that defined what we're sending in the MQTT transport. So Sparkplug, literally, it's a very simple specification that just sets out some rules. It doesn't change MQTT. It doesn't break it. MQTT 3.1.1 still is the same. All we're doing is we're defining a topic namespace, a data model capability, an OT-centric payload definition, and proper MQTT state management. Now, if we do that very simply without going into a lot of technical detail, what does an OT-centric topic namespace do? It gives us plug-and-play auto-discovery. Regardless of how, all the technical details, I can go in, now I can do a wildcard subscription into my MQTT infrastructure, and I can discover things dynamically. The second thing that it does is it lets us define a model from the edge. So, and Sparkplug template definition allows us to create a model. Then, when we instantiate those template instances, we've created assets. And those assets then contain our Sparkplug process variable object. Now that measurement has a name, it has a value, it has a timestamp, it has a data type, it has engineering units and ranges. It's got any other custom property we want to add to that measurement. So instead of a nebulous register value pair up into a data lake or into an S3 bucket, now, if we go find that measurement, it's an object. We know where it came from, and we know when it was sampled, and we know everything about that. And then finally, with proper state management, that lets us do store and forward so we don't have any gaps in our trend data. It lets us do report by exception and bidirectional command and control. So what does that mean? Well, what we're trying to do is we are all talking about all of this operational data that's out in the field, all this brownfield equipment that exists today in our factories, in our facilities. Those could be sensors, those could be protocols, but no matter what, we need to be able to take those into applications or devices that have implemented Sparkplug. So that could be a native device like a sensor. It could be an application that's running on an edge of network device. It could be an application running in a Docker container. Now, from there, we're able to take those brownfield values and give them context. So I can create a Sparkplug template that defines the model of something that I might be monitoring. That might be a tank level with a temperature and a high and a low tank level switch. That might be a motor with its amps and its RPMs. But whatever it is, I want to be able to create a model, and you'll see why here in a moment. Now, once I've created that model, I can now reuse that model. So I've created an asset, and that asset then has my measurements. So now I've got the ability from the edge of the network to define a model, to publish that, to be able to discover that model dynamically, going back to our plug and play capabilities. I can do automatic discovery. I can discover there's a model. I can discover there's an asset. I can see that that asset has measurements, and those are all defined within the Sparkplug specification. So now I can publish those into my MQTT infrastructure. So what does that have to do with Amazon? So what we were doing, and again, just by sheer customer engagement, by working with customers, we started 4 or 5 years ago. We were just publishing all of these process variables, Allen Bradley registers, Modbus registers, Siemens registers, OPC UA information. It was just all going into a data lake. And we were finding that we weren't fixing a problem. We were just moving the problem. We were moving the problem from the factory floor up into a data lake, but we still had to engage a village of programmers to take that data out of the data lake, put it back into the context that we probably knew operationally, which said, oh, that RPM and that amperage and that start-stop, those are associated with this motor. And we should have known that originally, being able to go all the way down to the factory floor. So we started piecing that together. And then, interestingly enough, Amazon came out with a new service called Sitewise. And Sitewise is a cloud service that, guess what? It lets you build a model. Once you've built that model, you can instantiate it, and that creates the asset. And that asset has measurements that all go into a time series database. So this was a perfect marriage of taking the capabilities that we had with MQTT, with Sparkplug, and now with a new service from Amazon called Sitewise. Now, Pugal, I'll let you kind of comment on, from the background, from your perspective, what was the kind of the impetus then behind the development of Sitewise?
Yeah, sure. Thanks, Arlen. Obviously, you have given a huge amount of background on why we have done what we have done. If you look at Sitewise today, one of the main reasons we developed Sitewise is because there is consistent customer ask that we got this data locked up in our proprietary PLC, SCADA as historians. Is there any way we can derive insights into this data? And also establish a meta model. So when we are trying to access this data, we can do a discovery process or analysis to the data from a machine level, line level, or at a plant level. At any level, you can establish a meta model and drill into it. That's the whole vision behind why we set up Sitewise, where in matter of hours, we can leveraging Sparkplug and all the fun stuff which Arlen talked about. We can provide seamless access to the data into the cloud, and we provide single pane of glass view from Sitewise into all our AIML services. So you can derive insights from millions of tags coming over from thousands of machinery around the world. Now you can see the magic happen around deriving insights. And also another major development on our side, this whole capability of Sitewise, which started with a cloud-based service offering, we have announced it for edge as well. So customers who do not want to send all the data to the cloud or want to do some analytics at the edge, it is possible. Absolutely, whatever this asset model and all the other things which Arlen talked about is very much possible. That's the background why we built it. And this is a foundational service for our industrial IoT offering. Thanks, Arlen.
Great, thanks, Pugal. So, kind of the epiphany here is that we wanted to be able to put together demonstrable proof of value, if you will, very, very quickly. And I know a lot of you on this webinar have seen all of the tools you have from any of the cloud service providers, but my gosh, where do you get started? You know, what do you use this feature, do you use this service, where do you get started? So what we were able to do in working with Amazon is being able to take devices that implement Sparkplug, that let us create these models at the edge, and with no programming or code required, be able to connect into, well, conveniently, AWS IoT Core, right? That was one of the first MQTT servers that the cloud providers put up there, was AWS IoT Core. Well, then we created a module, CirrusLink did, called IoT Bridge, that simply, it subscribes to our MQTT Sparkplug messages coming from IoT Core. And then it looks over in Sitewise and it goes, oh, you don't have one of those models, I'll create it. So we're moving from, the edge of the network, from the factory to the messaging infrastructure. Again, we want to do that with low code or no code, if at all possible. We want to make this, brownfield to cloud in a day, so that we can start actually doing something interesting with the data and quit spending man months simply trying to get the data up into a data lake, and then we still don't know what to do with it. Then with that, with IoT Bridge, once we built the models, we built the assets, and now we publish the data messages from Sparkplug, flow directly into the time series database that's on AWS IoT Sitewise. So you can see here that what we've put together, now there are going to be a lot of other capabilities that we build onto this, but to get started and to get our information into the right model, so that data analysts and the customer can start experiencing that data, is now become very streamlined. And it's because of what we can do with Sitewise and then the other services that Pugal and his team have put together. So Pugal, with that, I'm going to go to this next slide for you to talk a little bit about what you guys are doing once we get the data and the models up into the cloud.
Awesome. Thanks, Arlen. As Arlen mentioned, my role in the company is to drive solutions for driving business outcomes customers are expecting for their various industrial initiatives. Today, let me start with Industry 4.0 initiatives. This has been happening for quite a few years, at least a decade or so, ever since this buzzword originated in Germany, which is nothing but data-driven insights. There is all sorts of numbers in this slide on business value propositions around deriving insights out of this plant floor data, which is locked up obviously within their PLCs, SCADA devices, and historians. If you derive insights, Industry 4.0 talks about anything from 10 to 20 to 30% improvement in their manufacturing efficiency or supply chain efficiency. Depending on the customers you talk to, industry segment, the maturity of them. Again, all these numbers comes from analyst organization and partners we work with. What is Amazon seeing in this front? Our best numbers I have is public domain information from Volkswagen. The largest industrial IoT initiative happening today is a partnership between Amazon and Volkswagen. Their published number talks about 30% improvement in their manufacturing and supply chain efficiency, leveraging the capability like Sitewise, which we mentioned earlier. I think that's pretty much what we are expecting to do with customers, build solutions with capabilities like what Arlen talked about earlier, which liberates the data which is locked up within these proprietary devices for decades and provides a meta model on top of it. So we can get into building solutions with the AI/ML. That's what customers are expecting us to do to get to this manufacturing transformation they have been attempting for quite a few years. This is pretty much the vision. But again, there are some challenges for customers to get there. If you go to the next slide. One of the biggest challenges the customers face today is this. I have seen it in my earlier, before I came out to Amazon, in my Siemens career, as well as in my AWS career. Customers start on a proof of concept where they try to connect to few machines at the best and free up the data, which is whether in their PLC or SCADA devices, and they come across the whole bunch of challenges. There is a whole bunch of protocols in which these machines talk to each other. Modbus to MT Connect, depending on which machine industry segment you go into. Literally, there are 300 plus protocols. So what we call it as undifferentiated heavy lifting is what happens, where customers are trying to solve this IT-ish and OT-ish problem, trying to convert these protocols, building an hybrid architecture spanning edge and the cloud. There is inordinate amount of challenges they go through to free up the data which is stuck within these devices, and also establish an architecture which can scale beyond few machines into few lines into few factories. This is a consistent problem we are seeing in the industry, and more so in an environment where manufacturing world, they are not builders like a lot of other customers Amazon deals with. They buy solutions. They are expecting business outcome driven solutions out there. That's pretty much the expectation. And again, our goal as part of this partnership we have established with partners like Cirrus Link, Inductive Automation on this front, is to make availability to this data, democratize this data which is stuck within these proprietary machines, and free up the data. And now you can leverage this unlimited compute cloud offers to get into a deep insights into this data, which was not possible earlier, because now the technology is there. Big data analytics, AI/ML, all these technology is mainstream now. The challenge is getting access to the data. The other one, which obviously Arlen articulated so well, is unless you align the IT world and the OT world together, it's extremely difficult to get insights, because it's not just deriving insights out of the OT data. It is also you need to bring the data together into an IT world where the OT world lacks the meta model, but the IT world, whether it is a MRP system, MES system, has got a very rich meta model associated with that. Now, with an offering like Sparkplug and MQTT kind of protocols, now you got a richer meta model. And instead of a swamp of data in the cloud, now you got a pretty rich data model which has a meta model around that, and you can derive insights out of it. This is pretty much what we want to solve Amazon. This is the challenge we have seen consistently from customer. So if you go to the next slide, that's why we built what we call it as an Industry 4.0 accelerator, where we leverage a foundational service like Sitewise, which provides this asset modeling capability, which also provides this single pane of glass into every service we have, whether it's an AI/ML service or data modeling service, we have it available. We provide that capability where you can derive insights. Obviously, for us to be successful with a service like Sitewise, we need access to data with these multiple protocols and all the other things which Arlen talked about, I mentioned as well. We make that available with deep integration we have with Cirrus Link and Inductive Automation, with Sparkplug and various products like that, where we get access to the data. We have a programmatic way to discover these assets and transfer the meta model into cloud. Now, if a line manager wants, a line supervisor wants to do a root cause analysis, when a line goes down or a machine goes down, they can do that in a near real time with the capability we offer from edge to the cloud, seamless integration. And along with that, we can also provide predictive analytics, experience-based learning, all the other things which industry has been talking about for nearly a decade. It's possible today. That's why we have partnered heavily with Cirrus Link on this front. We are working with multiple customers on this business transformation journey. And back to you, Arlen.
All right, thank you, Pugal. Appreciate it. So I hope this was kind of an interesting insight of how we're leveraging, what the Sparkplug working group has been working on over the last year. I hope that everybody, I put the URL to the Sparkplug working group. And again, we would really encourage everyone on this to go and look at what we're doing. Look at some of the companies that are part of the Sparkplug working group. I think Frederick and I can both tell you that there are many other companies looking to join the Sparkplug working group. It's been very dynamic. The Slack channel, I believe, has close to 200 participants in the Sparkplug working group Slack channel. So I would invite everybody to go look, see what is being done. To Frederick's point, the University of Sheffield have done a very interesting specification called Factory Plus that leverages MQTT and Sparkplug in many of the same aspects as that of what Pugal and I just talked about today. So again, Frederick, that's the end of our presentation. I don't know if there's any questions or not, but I will move this out of the way and turn on my camera.
Yep, so we've got 4 questions, in fact, so it won't be... questions won't be a problem. So let's start with the first one by Hamitab, and he's asking, or they are asking, I shouldn't assume anything. So they're asking, how can we reconcile models in Sparkplug with digital twins in the cloud? What do I have to worry about in terms of mapping the definitions?
Well, I've been doing this for 40 years. I sat on the board of directors for the Heart Communications Foundation. I sat on the Field Bus Foundation board of directors. I have seen 35, 40 years of people trying to come up with a model to begin with. And so far, correct me if I'm wrong, that hasn't worked. I mean, even a lot of the OPC UA models, they're out there, but I don't hardly have any customers that are using them today. What's going to happen is, just like Pugal and I, is we're going to get on a call with the customer and they're going to go, you know what? Here is our stamping machine, and by golly, here's how we want to model it. And if you look at the Sparkplug spec and the way that it's constructed with Google protocol buffers, you can build a model just the way the customer wants it. So literally, Pugal and I are on the phone with a customer, and we're building the model the way the customer wants to see it. So if you ask me, are we dictating a hard-coded model? No. Are we putting together a set of names, attributes, measurements that the customer understands and we can publish and it be automatically put into Sitewise? Yes, we are doing that. So I don't know of anything that you could come up with, because Sparkplug lets you give a measurement, it lets you give it, engineering units, it timestamp, and you can put those together any way you want within the Google protocol buffer hierarchy of a Sparkplug measurement object.
Okay.
So if I add to that, Arlen, since it's digital twin, one of my area of interest, and I deal with it daily with customers. So it's a very good question as well. For you to construct a digital twin, whatever is the rationale behind it, whether it's a remote asset, you would like to visualize the performance data, or you want to perform a what-if studies around it, the asset modeling we are doing is the key, because that provides the complete information on the asset, what you're trying to model. That's one. And the data, what it is coming out of that asset, whether it is a spindle RPM or vibration or voltage, power consumption, and things like that. Once that asset model in place, digital twin, you may or may not need one or two information out there. One is a visual representation, with which you can visualize the asset. Another one could be a model around it, which is going to provide behavioral information. That model could be constructed either a physics or a multi-physics model, or it could be based on AI/ML model. So bottom line, with this Ignition, Sparkplug, and the Sitewise capability we talked about, it provides the foundational modeling capability around the actual asset in a plant floor or a car or a truck or an excavator operating in a remote environment, On top of it, you can always bring in a visual model as well as a behavioral model to simulate and do what-if studies. That's how we see it working. And in fact, I have done this multiple times with our customers in the pretty much how I explained now. Thank you.
All right. Thank you so much for the additional details, Pugal. Our second question from Vasil. Could an instantiated information model of a specific asset be dynamically extended?
Well, yes and no. I mean, once there's several areas, right? Once you've created the model, whether it's in Sitewise or some of the other cloud modeling tools that we've seen, is that once that model has been created, then you can extend it. But remember, you don't want to get into a round robin of you've created a model at the edge, and then it comes up and you've added to it, and then you've created, then you do that model again at the edge. So who's the single source of truth there? We try to push it to the edge if at all possible, because again, you may not be the only thing consuming that message, right? That's this whole notion of publish it once, discover it, use it. If you want to redefine that or add to that, go all the way back to the edge and put that augmentation or that extra capability all the way out of the edge. Because again, if not, we're going to get into that mode where, oh gosh, they changed it here, we're going to edit it here, and this other application, I got to edit it down here. And we'll be back where we are today, where people with operational systems have engineers that it's their full-time job to double click and edit tags. It's just the care and feeding of a model that just doesn't work.
All right. Excellent. The next question is by Mao, and they are asking, AWS IoT Core does not fully support Sparkplug B, such as retention. So I suppose does not fully support Sparkplug B features such as retention. So then do we have to modify the specification a bit to accommodate that?
That is true. Everyone at Amazon knows that you're right. Retain and the death certificate are not supported by AWS IoT Core. So we have two recommendations. Number one is that you can quite easily instantiate a 3.1.1 compliant broker in an EC2 instance and run that. And then what CirrusLink have done is that our IoT bridge takes care of the in-order delivery and the retain that isn't available in the standard IoT Core. Now, having said that, we've been using IoT Core probably for the last 5 years in anger. It is a very well-managed service by Amazon, and we really haven't seen a lot of problems with that regards. And again, remember, death certificates and retained, if I was on a pipeline system like Phillips 66 or in a manufacturing plant where we're actually controlling machines, then you're right. We would go with the 3.1.1 compliant broker. But remember, we've got store and forward. We've got all that capability with transmission with Sparkplug, with the Sparkplug client. And so we can maintain that through IoT Core and not have to worry about that. We're not doing mission critical command and control.
Yeah, so given the respective scopes of what's happening on the factory floor versus what you send to the cloud, then the fact that we are lacking the feature in the cloud is not that grave in the grand scheme of things.
That's a good point. Yep.
All right. Last question, at least for now, by Shant, who is certainly the MVP for questions today, so congratulations. I understand that Sparkplug uses protocol buffers for payload definitions. If the payload specs change, there can be significant downtime for systems in terms of being Sparkplug compatible. Does the working group has some insights on how such gaps could be tackled, since being compliant is always very important for quality assurance of data in industries?
That's why it's called Sparkplug B, because we know there's going to be a Sparkplug C and a Sparkplug D and a Sparkplug E. So very good question, but we, as you all know, we used an existing Eclipse schema that came from Eurotech originally, and that was Sparkplug A. And then we had a ton of feedback from all the customers. And I go, well, what about this? We need the ability to build a model. We need all of this. So that's where Sparkplug B came from. And there's already discussions within the Slack channel on, oh, I would like to do this, and maybe that dictates a Sparkplug C. But at least I know that Sparkplug B, I'm using this protobuf definition, and if that changes to where it breaks B, then we're going to go to C.
Yeah, and since the Sparkplug specification is developed in the open on GitHub, it's not like anyone will be surprised by any changes that would be coming, right? It's we're not building this behind closed doors, so any change will be visible there and then communicated well in advance to the community.
Yes.
All right. So thank you once again for the question, Shant. So if there are no further questions, I think, well, the only thing left is to say a big thank you to you, Arlen and Pugal, to come to our event today and share this with us. And if people want to learn more, as you indicated, Arlen, there's the Sparkplug website at sparkplug.eclipse.org that contains a wide variety of information. And Pugal, if people want to learn more about the AWS side of things, where should they go?
It's AWS IoT website, Frederick. It's pretty simple. I think that's where all the information is. Yeah.
Okay, fantastic. Yeah. So once again, thank you to both. And oh, we've got the last minute question. So from Vasil, asking, would you please say some words about OPC UA and its correlation with the digital transformation? Is the protocol too heavyweight compared to MQTT?
I try very, very hard never to get into a OPC UA versus MQTT. They're both very valuable. They both have their place. I think that, to your point, one of the things I point out is that the entire MQTT spec, the original one that Andy and I created, was 18 pages long. I think the other thing that we do is we leverage TCP/IP. So a lot of people say, well, Arlen, we can't use MQTT. We just read the spec and there's no security. Well, we put MQTT right on top of TCP, and we let TCP do a lot of the heavy lifting. And you're right. So for a lot of what we're doing, remote connectivity, bring all this information from the factory, OPC is too heavy for that. Now, for the factory floor, for legacy devices that we're connecting into, OPC UA is fantastic. So I think they both have their place. I don't want to say it's a, us versus them. I think that we put it together and we use the best of both.
Certainly. And Mao added a comment on that question, adding that OPC UA pops up, it seems, actually uses MQTT as the transport. So there is still some some level of integration there. And the other thing I would like to highlight is that what Sheffield University did at their Advanced Manufacturing Center was really to bring part of the payload definitions from OPC UA, or at least some subpart of OPC UA, and then they were using that on the top of Sparkplug, right?
Yes, they are doing that mapping. But again, for the 30 years that I've been using OPC UA in industry with my customers, I look out there, I don't see any of them using the OPC UA data model. Now, again, that could be because they're water, wastewater, oil, and gas, but they aren't leveraging that model like they should be right now. And I think what we've done with Sparkplug is we've made that modeling so much easier and dynamic instead of very rigid and hard, that we can be serendipitous with the customer so that he actually gets what he understands. So many times we go, oh, well, gee, we can't use that data model spec because we wanted to add these 3 things and it doesn't support it. And with Sparkplug, we can easily add that into the data model.
Yeah, indeed. And in any case, ultimately, it's up to developers to choose whatever works for them, right?
Yeah.
In the sense that, well, at the foundation, we've got Eclipse Milo as an OPC UA, very active implementation there, Java-based, very robust, and very active. And then, obviously, the Sparkplug working group and the Eclipse Tahoe project as an open source implementation. And both of those things, are on their own roadmap, so to speak, in the sense that ultimately it's up to developers to pick the right tool for the job.
Yep.
So we've got another semi-question or comment from Taichi there, highlighting that yesterday we had a presentation from Jan Skerrett on the usage of MQTT in the connected vehicle. And Taichi is remembering that we were going to ask you, Arlen, about the potential use for Sparkplug in V2X applications in the case of automotive. So do you see that happening? Jan was skeptical about this in the sense that he saw Sparkplug more tightly focused on industrial automation, but in theory, anyone could define V2X payloads and use that on the top of Sparkplug as well. So what's your take on Sparkplug in automotive in that context?
Well, I can't say I'm the automotive expert. I know from Tesla to everybody, they're using MQTT to communicate from the car back. I know that for a fact. I think that part of the Spark, that self-discovery where you could publish and, hey, I'm a Ford F100 and here's all my information, and I've been upgraded, and here's my current version of firmware and things like that. I'm sure since Sparkplug kind of came in behind that first telematics rollout, that a lot of the entrenched players probably already have developed their Sparkplug like messaging that they're already using. But I would say that if all of them were to start from ground zero today, I think they would be very interested in taking a look at that. But again, I'm not the subject matter expert on what you would do with the connected car, if you will.
Yeah. At the same time, I think one of the things, without naming names, but we've been involved with car makers or even car makers association that are looking at Sparkplug right now.
Yeah. Yes. Many.
So maybe stay tuned, and next year we can say more about that.
We can say more about that. Yeah. But I will say that Pugal and I were on a very interesting webinar last week with Carrier, where Carrier has announced globally through all their HVAC, all the way down to their home thermostat, is that all of their digitization going forward is standardized on Sparkplug B as well.
So looking forward to see them participate in our upcoming compatibility program and see all of those Sparkplug compatible stickers all over the place.
Yep.
And we have another question. Keep them coming, guys, from Wenderson. Hello. Are you considering moving from gRPC to Kafka in the future releases for exchanging messages between nodes?
Whoa, that one's a little over my head. We do have a lot of customers using Kafka, so it's very easy for Kafka to basically plug into MQTT. You can write a simple transform and pull all that information into Kafka. We have many customers that are using it, but I think they're all using it probably a little bit differently. So again, I probably wouldn't be the expert on how they are leveraging Kafka, but I know that it's got some really good MQTT tooling on it.
And I think there's maybe some confusion there, because essentially you are using the Google protobuf format, which comes from the gRPC universe, from what I understand. I'm no specialist there, but we are not actually using the whole gRPC stack in any of those communications.
No.
So in that case, as you mentioned, Arlen, I mean, the messages can be ingested to Kafka or to some other platform without any trouble, as long as
Kafka and InfluxDB seem to be the two other big ones.
Yeah, and Shant is making the comment that gRPC uses HTTP version 2 and is more focused on the web world rather than in a broader perspective industrial automation,
Right.
which is quite a good comment there. All right. So that was our last question, it seems. So once again, thank you, Arlen, and thank you, Pugal, for this presentation. Thank you all for the great questions. This kept the conversation going and added quite a few interesting details. Obviously, this will be available on YouTube later today if you want to watch the replay or send the link to your friends. And well, please stay with us for the next sessions. Two sessions left in this virtual IoT and Edge days, and two very interesting ones. So Arlen and Pugal, thank you again, and see you around in our Sparkplug community meetings.
All right. Hey, thanks, everybody. Have a good day.
Bye.
Bye-bye.